Good morning, students. Myself Suresh, Assistant Professor, Department of ECE. I am going to present a topic today, transistor from electronic devices. So, what is actually transistor? Transistor is a three-terminal devices. So, it will be useful for, it will be coming from, that is diodes. After the diode, we have to implement the transistor. In the transistor, we are having the three-terminal. For the different types of transistor, we are having different types of terminal names. For example, for the bipolar junction transistor, we are useful as the name as three terminal as emitter, base and collector. So in the transistor, why we have to go for the transistor? So every devices, electronic devices, we are having some special applications. So the transistor mainly it will be useful for, there are two purposes we are using. One first main purpose, it will be useful for that amplifier. So what is actually amplifier? So we know we are using the mic. So we know everyone, we are know the mic. So what is the purpose of mic? So our input we are given from our mouth, that it will be the low signal. That low signal it will be amplified. It will be produced from the mic, it will be getting that high audio. So which means that it will be produced that amplified signal. That is the purpose of transistor we are using, that is it will be acting as an amplifier. Then second, the transistor it can be used as a switch. So switch means we know that it will be acting as on and off switch. So then in this transistor, so many category we are having. Out of the transistor majorly it will be classified as BJT, FET. What does BJT means? Bipolar junction transistor. And FET. What is FET means? Field effect transistor. In the FET we are having so many category, that is JFET, MOSFET, like that so many category we are having. JFET means junction field effect transistor, MOSFET means metal oxide semiconductor field effect transistor. We are having so many grades of transistor we are having as per now the integration of the number of devices. So out of the transistor, today we have to discuss about what is BJT. What is BJT means? Bipolar junction transistor. What is bipolar junction transistor means? That bipolar. What is actually bipolar means? Generally we know, already we discussed what it will be on that type of semiconductor we are having as there are two types of semiconductor. One is p-type semiconductor and another one is the n-type semiconductor. Out of two types of semiconductor, we are having two category of carriers we are having. One is majority carrier and another one is the minority carrier. So in p-type, we know the majority carrier as hole and minority carrier as the electron. And n-type, we are know that the majority carrier it will be the electron and minority carrier as the hole. So these are all the different carriers, majority and minority carriers. So what is actually bipolar means? The flow of both the majority and the minority carrier will be takes place. That's why we call the name as bipolar. That bipolar transistor we have to call that. So what is that bipolar transistor? We have to call the name as BJT. That is BJT transistor. So what is actually BJT? How we have to manufacture the BJT? BJT actually we have to manufacture as the back-to-back connection of two diodes. Generally we know the diode can be classified as so many category. So we know the basic diode, we know that p-n junction diode. What is actually transistors? That two diode we have to connect it as that back-to-back. So already we are having the diodes. Why we have to go for the transistor? That is the question we are having. So why we have to go for the transistors? That we have to go for some special application. That is the purpose we have to go for the transistor. So in this, the transistor we are having, there are two categories of the transistor. What are the types of transistor we are having as? One is NPN transistor and another one is the PNP transistor. What is actually NPN transistor means? That p-type semiconductor it will be doped between two n-type semiconductor, that is we have to call it as the NPN transistor. And what is PNP transistor means? The PNP transistor will be that the n-type semiconductor will be doped between two p-type semiconductor we are having. So it depends upon the doping, we have to classify the terminals of transistor. What are the three terminals of transistor we are having? Emitter, base and collector. In NPN transistor, the emitter terminal is the n-type semiconductor, emitter and collector is the n-type semiconductor, base is the p-type semiconductor. In the PNP transistor, emitter and collector is the p-type semiconductor and the base is the n-type semiconductor. So then in that NPN and PNP we know as per the construction. So that what is actually transistor I told us, the transistor is that back-to-back connection of two diode, two p-n junction diode, that is we have to call to be as the transistor. So how we have to differentiate the NPN and the PNP transistor? In that NPN transistor we are having three terminal, one is emitter, base and the collector. Emitter is that heavily doped, base is that lightly doped and collector is that moderately doped. What is actually doping means? The adding of impurity to the pure semiconductor, that is we have to call to be as the doping. So in this what we have to go for us, in that NPN transistor, where the emitter direction it will be that outwards. In that PNP transistor, the emitter direction it will be inwards. So that is the difference between the NPN transistor and the PNP transistor. So according to the doping level, we have to classify the area. So emitter it will be that heavily doped, that is it will be that more number of majority carrier we are having. Base is that lightly doped, because via that base only we are the flow of carrier will takes place from emitter to collector. So due to that the base with it will be the very small, so it will be that locked by the less area. Then collector it will be the moderately doped, but most of the carrier it will be flow from emitter to collector, so the collector it will be that larger area. So that's why only we have to go for the emitter it will be that heavily doped, it will be consist of majority carrier, via the base it will be boost, so it will be the base will be the lightly doped, and the collector will be collecting what are the majority carrier, and it will be the minority carrier it will be takes place from that emitter to that collector. So the collector finally the collector is that it will be getting as the output, emitter is the input terminal. So via the base from the emitter to the output, that is the collector, the current it will be flows. So that is it will be called to be as the BJT system. So the next one, so that it defines that NPN transistor and then PNP transistor. So the next one we have to go for that the operation of that BJT transistor. So generally we know that what is actually bias. So what is actually bias? So without bias the transistor cannot operate. What is actually bias means? We know that bias means we have to give the supply. So you know that in PN junction diode we know that what is actually bias. So here also the transistor we have to move for that bias. What is actually bias means? We have to give the supply for that BJT transistor. So generally there are two supply we have to given over here for that BJT transistor. From the diagram we know that what are the we are having. So we have to know that NPN. What actually I told us? What is actually I told us transistors? Transistors that back-to-back connection of that that is two diode. So one single diode we are having one junction. Because of the two transistor we are the two diodes which will be connected back to back, we are having the two junction. One is we have to call it as the between emitter and the base, and another one transistor we are having, that is another one junction we are having between collector and the base. So there are two junctions we are having because we are having the two diodes. So generally we got to consider as that emitter as the input, emitter base junction as the input, collector base as the output. So emitter base junction we have to consider to be as that forward bias. Generally we have to give what is the type of supply we got to give it as that forward bias at the input side. Why we have to give the forward bias? That is the reason we have to know that. But why we have to give the forward biases from emitter to the collector? We got to transfer the majority carrier. So due to that, at the input side we got to give the forward bias. At the output side, what we have to give it as? We have to give the reverse bias. So what is output side as? Between collector to base junction. Between collector to base junction, what we have to give it as? Reverse bias. Generally we know what is the difference between forward bias and the reverse bias. Forward bias means the depletion region will be very small. So because of the depletion region will be very small, what is actually forward bias? The P will be connected to the positive, N will be connected to the negative. Due to that, that is the same charges, what will be happen is the ripple will be takes place. Due to that, the depletion region width will be reduces. While the depletion region width will be reduces, what we have to conclude is the resistance will be very small under the forward bias. So due to that, the more number of majority carrier will be flow from one region to another region. So from this, what I have to conclude is under the forward bias from the emitter to the base, the more number of carriers, that is more number of majority carriers will be flowing from emitter to collector via the base. So why we have to keep the collector base junction as the reverse bias? Why? What actually reverse bias means? The P will be connected to the negative terminal, N will be connected to the positive terminal. So due to that, the same charges of connection that will be takes place that attraction. That is the ripple charges. It will be takes place that attraction. So due to that attraction, the depletion region will be wider. So due to that, it will be having the high resistance. So due to that, the collector base junction we have to give it as the reverse bias. So from this, what I have to conclude is the emitter base junction will be the forward bias, collector base junction it will be the reverse bias. From the emitter to the collector via the base, the majority carrier from the emitter to collector it will be goes plus. Under the forward bias, the majority carrier it will be flowing. Under the reverse bias, even though the majority carrier will be absent, the minority carrier current will be takes place. So due to that, we have to call the name as bipolar. What is the meaning of bipolar? Under the forward bias, the majority carrier will be flow. Under the reverse bias, the minority carrier will be flow. Because of that, both the majority and the minority carrier flows, we have to consider to be as that BJT as the bipolar. So that is the operation we got to consider. So while we got to go for that application wise, while we got to explain the BJT transistor as that operation, for one basic example we have to take. What is the example as that? We got to consider the tap. So in the tap, what is the input we have to consider to be as the emitter, the tap connection that it will be considered, that is on and off switch we got to consider to be as the base, and the output we have to consider to be as the collector. So outlet what we are getting as the, that we have to consider to be as the collector. So at the emitter we have to give the force. That means that at the input side we are giving some force. What the force we have to give it as voltage or current we have to give it as the force, and what we have to get it as that output as that the current flow, that water flow we got to consider to be as the current, and outlet what we are getting as that output, that is we have to consider to be as the collector. So output what we are getting as that outlet we have to consider to be as the amplification. So that means that the output from the tap, so what it will be getting as, that is the output we have to consider to be as the collector. From the tap we are getting that water outlet. So that water we got to outlet we got to consider to be as the amplification, which means that the transistor it will be acting as that amplifier. So that is a major application we have to go for. So that is we have to consider to be as the transistor. So generally the transistor can be classified as three category of configuration. One is BJT, that is common base configuration. Then next second one we got to consider to be as the common emitter configuration, and third one we got to go for the common collector configuration. Why we are going for the different types of configuration? As every transistor configuration it will be acting for the different types of application. So for that purpose only we got to go for that different types of configuration we got to go for, that is common base, common emitter, and the common collector configuration. Then first one we got to go for the common base configuration. So in this configuration what we got to go for? So what is the connection we are given? Which one we are to take it as the input? Which one we are to go for that output? Which one we are to take it as the common terminal? That is we got to consider to over the configuration, and also we have to draw the characteristics. So for this particular configuration, what is the characteristics, what it will be useful for that special application. So that is the purpose we have to go for that configuration. So first one, common base configuration. In the common base configuration, the base is the input terminal, emitter is the base is the common terminal, emitter is the input terminal, collector is the output terminal in that common base configuration. So between the base and that emitter it will be acting as the input side, the collector and the base it will be acting as the output side. So that is it will be considered to be as that at the input side we have to give the supply, as well as the output side we have to give the supply. Emitter base junction always should be the forward bias, collector base junction it will be always it will be the reverse bias. Base is the common terminal, emitter is the input terminal, collector is the output terminal. So that is we have to consider to be as that. Then next one, what we are going to discuss is what is the input characteristics, what is output characteristics, what is actually input characteristics. We have to find out the input characteristics. Why we have to go for that characteristics as that? We have to define the what actually the particular configuration, how it will be working. So that is we have to consider to be as that configuration. So in this common base configuration, input characteristics means what actually input characteristics means. We have to plot the graph between the input voltage between input current for the constant output voltage. So we have to draw that between the input voltage and the input current, we have to draw the curve. So it will produces that we have to get it as that we have to plot the graph between for the constant output voltage, we have to draw the graph. That is we got to call to be as the input characteristics. While we got to consider to be at the input side, generally we know what is the input side we are having for the common base configuration, that the emitter base side. So emitter base side it will be the forward bias, while it will be the forward bias it will be acting as the normal PN junction diode. Look the curve, it will be like, looking like the forward bias the junction of the PN junction diode. So the curve it will be the normal PN junction diode. Then we have to draw the output characteristics we have to go for. What is actually output characteristics we have to plot the graph between? We have to plot the graph between the output voltage versus the output current for the different values of constant input current. So that is we have to cultivate that output characteristics. Why we have to go for that output characteristics? There are three region of operation we are having. What are the three region of operation? Why we have to go for that output characteristics as that? One is cutoff region, second one is linear region, and third one we have to call to be as the saturation region. So what is actually each region we have to consider to be as the cutoff region means both emitter base junction and collector base junction, both it will be that it will be on the reverse bias. That is we have to call to be as the cutoff region. Under the cutoff region, the transistor it will be off, which means that there is no current will be flowing over the transistor. The transistor will be off. So what is cutoff region means both the region, emitter base junction as well as the collector base junction, input side as well as output side, it will be on that off condition. That means it will be on that reverse bias. Under reverse bias means there is no flow of carriers due to the majority carrier. So it will be considered to be as that the transistor will be off. Then second one, it will be considered to be as that linear region. What actually it will be linear region means? Linear region means the emitter base junction at the input side it will be that forward bias, and the collector base junction output side it will be the reverse bias. That is it will be that active region. And the third region we have to go for that saturation region. What is saturation region mean? Both the region, emitter base as well as collector base, the input side as well as output side, both it will be in that forward bias. So while it will be that linear region, what actually in the second region the current will be that linear. So what is actually linear? We must know. While we have to increase the voltage, input voltage, the current is also it will be increases in the linear manner. So while the voltage will be increases, the current is also increases. That is we are called to be as the linear region. What it will be the third region is the saturation, both the forward bias as well as the reverse, that is the input side as well as the output side, both it will be under the forward bias. Both it will be under the forward bias means the current it will be goes, the transistor will be going to saturate. What it will be actually going to saturate? Saturate means after that current cannot be increases, the voltage it will be, while after the voltage is also increases, the current it will be maintains a constant. After that saturation point, the current cannot increase. That is we got to call to be the saturation point. Under that, the more current it will be flowing over the saturation point. After the saturation point, current it will be maintained a constant, because after that saturation point there is no increase of current. It will be the voltage it will be maintains the constant. That is we got to call to be the common base configuration, the three region of operation. So this is we have to discuss over the points already. So the next one what we got to go for is so what actually we are having. So according to the tab, we know that cutoff means both it will be off. So due to that there is no water will be coming from that outlet. And the next one is linear. So under the linear, the input that will be the forward bias, output it will be the reverse bias. Due to that the limited number of water will be coming at the outlet. And third one is saturation region. Saturation region means both the emitter base as well as the reverse bias, both it will be the forward bias. Due to that, the more current it will be coming as the outlet. So that is we have to conclude over here. The next one we have to go for that common emitter configuration. So in that common emitter configuration, similarly the emitter is the common terminal, base is the input terminal, collector is the output terminal. Similarly we have to discuss all, that is input characteristics, output characteristics. If the input characteristics means we got to draw the plot the graph between input current versus the input voltage for the constant output voltage. Output characteristics means it will be defined the current, the output current with versus output voltage for the different values of input current. Similarly here also classified the three region of operation, cutoff, linear and the saturation. Then we have to go for the next one, common collector configuration. So while we got to go for the common collector configuration, so what we got to go for us in the common collector configuration, the collector is the common terminal, base is the input terminal, the collector is the output terminal. So while here also we have to go for that there are different types of transistor. We know that PNP as well as NPN. So depends on that we have to draw the curve. So in this common collector configuration also we have to classify the two characteristics, one is input characteristics and that output characteristics. Similar here also we have to plot the graph between the input voltage versus input current for the constant output voltage, and output similarly for that output characteristics we got to plot the graph between output voltage versus output current for the constant input current. And in this also region also there are three region of operation, that is cutoff, linear and that saturation region, similar to that other configuration. But while we have to go for that application point of view, so we have to use it as the common collector configuration. It is also called to be as the emitter follower, because in that emitter follower we have to consider to be as that why we have to call to be as that emitter follower is that in this common collector configuration the emitter is that output. So due to that emitter as that output, because of the emitter as that output, we are called to be as the common collector configuration as that emitter follower. Concluded over here. So generally I told us the BJT transistors that it will be acting as application wise there are two categories. One is we have to call to be as the transistor as amplifier, and another one we have to call to be as a switch, where it will be acting as that amplifier, where it will be acting as a switch. So already we had discussed in the characteristics there are three region of operation we are having, cutoff, linear and saturation. Cutoff it will be acting as purely it will be switched off, and the saturation it will be fully it will be on, because both it will be forward bias, it will be switched on. So the cutoff region and the saturation region it will be acting as a switch. During the cutoff region it will be the off, during the saturation region it will be on. So cutoff region and the saturation region it will be acting as the transistors, the switch. While the transistor it will be acting as a linear region. In that linear region it will be acting as an amplifier. So it is a best application of the transistor. While the transistor it will be in the linear region, or it will be called to be as the active region. While it will be active region, it will be acting as the best application as the amplifier. The amplifier is the best application for the BJT transistor. So generally we have to call to be as that, for each transistor we have to call to be as the gain. What is actually gain means the output current. While we have to consider to be as the current gain means output current to the input current. So that we have to call to be as the current gain. What is voltage gain means output voltage divided by the input voltage. That is we have to call to be as the voltage gain. And power gain means we have to call to be as the output power divided by the input power. Why we have to define the gain parameter as that? We have to analyze the amplifier. So what actually transistor, how it will be, can be used as that application point of view. So for that purpose, what we have defined as that, we have to define the gain parameter. So from this, what I have to conclude is we have to define the summary of the BJT. We know that there are 3 terminal transistor can be classified as many category, and we know that 3 terminal emitter, base and collector. Emitter is the heavily doped, base is the lightly doped, collector is the moderately doped, and depends on that we have to classify the area. And we know that there are 2 junctions, because the transistor is the back-to-back connection of the diode, and we know that there are 2 junctions we are having. One is emitter based junction and collector based junction. Emitter based junction is the forward bias, collector based junction is the reverse bias. And the transistor can be 3 configuration: common base configuration, common emitter configuration, common collector configuration. And there are 2 characteristics we are having: input characteristics and that output characteristics. In this we are having 3 region of operation: cutoff region and active region, and third one is the saturation region. So this is our summary regarding what we are still now what we completed over the BJT. Then next one, what are the possible questions under we are having. So as the point of your academic, as well as we are having as the point of your placement oriented questions. So what are the different we are having? What are the questions they are possible as that? What are the different operating region we are having? What is the application of BJT? Why, which region it will be the bigger, which region it will be the lighter? Why we have to go for this? What is the reason we have to keep it as the emitter as the heavily doped, and what is the reason we have to keep the base as the lightly doped, and what is actually pinch of voltage? And so many possible questions we are having. What is actually operating region, operating point? Why we have to keep the transistor? It will be the 3 different region. Which region it will be acting as a switch? Which region it will be acting as an amplifier? What is actually pinch of voltage? What is actually punch through? What is actually reach through? What is we call to be as the early effect? And what is the characteristics of an input and output characteristics of an each configuration? These are the possible questions they are asking as the point of academic as well as the placement oriented questions. So different, it will be the interesting topic what we are having that transistor. Okay. Thank you, students.